This video will introduce the symbols that are used in the videos on conceptual modeling. But first let's have a look at the diagram editors. So now I'm on the software page, which can be found here under this link. And here are some suggestions of diagram editors. So there are others as well, and none is perfect. They all have their pros and cons. I'm going to use astah now, not because by any means it's the best editor, but it's a decent editor, and we have licenses for all participants in the course. If you want to use astah, you can find the license here, this page that's linked here. I think also Lucidchart is perhaps definitely a good editor, maybe better than astah, and you don't have to install anything for Lucidchart. It's online. But we only have licenses for students in these programs. MySQL Workbench is also a nice editor, but it's very oriented towards MySQL databases. And in the conceptual model, we are only going to consider the reality, not any database. So it's a bit difficult to use MySQL Workbench for a conceptual model because it's so database oriented. So you start to think about databases instead of the reality. Draw.io is also online. By the way, both MySQL Workbench and Draw.io are free, so there's no need for any license. Draw.io is also a nice program, also web-based. You don't have to install anything. The problem is that the symbols used in Draw.io take up a bit more space than the symbols used in astah, so the diagram tends to be a bit big. I like the symbols that we use in astah better. So by the way, a few words about symbols before we get started. So there are many different standards for the symbols used in an ER diagram, there are simply different standards, or maybe it's better to say there are no standards, because people also use them. I mean, even if you say you use a certain symbol standard, many people deviate or are forced to deviate because the tool does not exactly follow the standard. So diagrams simply might look a bit different, and there's no point in deciding exactly which symbols you want to use and then try to find a diagram editor supporting that symbol. It's better to go the other way around, find a nice editor and just bear with the symbols used by that editor. And for the project, you're free to use any symbol set you like, as long as it's reasonably understandable. Okay, but you have to learn during the course some kind of crow foot notation, like the foot of the bird, crows, which is perhaps something like this, and you'll see soon why it's called crow foot notation, because there are symbols like this. Okay, you will learn that very soon, because in this video I'm going to use one of the crow foot notations. Okay, so let's start astah. So now I started astah, and I'm creating a new project, and I will create an ER diagram. ER diagram. So it's created, and I will use the IE, which is short for information engineering symbol notation. The IE notation, or at least the IE notation as used by astah, which is not perhaps exactly, well, there are just saying IE notation is not sufficient. It can be used different ways, but I mean the symbols are quite many of these notations use crowfoot symbol or UML style. If you're used to both UML and crowfoot notation, they won't be too strange. Okay, let's give a name to this diagram, which could be conceptual model. And the type should be logical model. Okay, so there are three kinds of models: the conceptual model, the logical model, and the physical model. But there's no conceptual model here in astah, so we use the logical model style, which is closest to the conceptual model. And we use the attribute display level, which is most detailed. Right, so now we're started and we're ready to place things on this diagram. So let's start with an entity. So there are different kinds of entities here, you see, but we'll only use entity. double-clicking, entity is the correspondence to class. If you draw a class in UML, you would draw an entity in a conceptual model or IE notation or whatever we call it, diagram. Right, and we can name this entity perhaps. Let's call it person. Let's say that this is a person database. But again, this is just to illustrate the symbol, not to model a person database or a person register. We're not supposed to talk about databases yet. Okay, then we can add attributes. So there are two marks here, a red and a yellow. The red one is an identifying attribute. Then an identifying attribute is an attribute that is different for different instances of this class. One person would have another value for the identifier. Each person would have a unique value for their identifying attribute. But I think here in the conceptual model, let's not bother about deciding identifying attributes. You can if you wish, maybe not wrong, but we don't gain much for that. No big point in thinking about whether an attribute is identifying or not yet. We will come to that later in the logical model. So let's just use the yellow mark here and create non-identifying attributes. So the person might, for example, have a name. Now the person has a name. And what about, what can we do with this attribute? Well, primary key, let's not bother about that yet. It means that it is identifying. If we check the primary key, it goes to the upper compartment, as you see here. It becomes identifying. Let's not care about that for now. Not null means that it must have a value. So we can specify, if we wish, whether it can be null, without a value or not. We can give it a default value if we wish. But let's not care about its type for now in the conceptual model, just as if you watch the videos on domain modeling, which I hope you have, because I will not go through that again. I will assume you watched it when I talk about the conceptual model. Just as in the domain model, when modeling the reality with the purpose of creating a diagram, we did not care about the type. I think also here we don't care about the type.
To say a bit about what to show, namely if we shall show the type or the not null thing. So as you can see now, nothing is shown here. Let's look at tools and system properties and the ER diagram here. And these two checkboxes, type decides whether to show the type or not, and the null option decides whether to show the not null thing or not. So now I changed and checked both. Okay, it didn't change here. That's because it doesn't change live. We have to redraw it, but we don't have to delete it entirely, everything we did. We just have to remove it from the diagram. So I highlight this one, press delete, not Control D. It still remains in astah's model here, and now I can pull it back, and now there's both the type and the not null. Okay, so that's how this is decided. Now what to do in this case? So in a conceptual model, we should definitely not have the type, so we remove that one. The null option, okay, maybe it's good to have the null option. Maybe we are interested in that. I'd say we are interested in that. But actually, I'm recording this comment about this settings for type and null option. I'm adding that to the video afterwards, as maybe can be heard from the sound. So I'll uncheck it now to make it consistent with the rest of the video where null option is unchecked. But maybe in hindsight it would have been better to, I think it would have been better to have it checked. So I suggest you leave it checked there. There.
Right, so that's that. Then there are a few other things that might be of interest for the attribute, namely its cardinality. That is, how many values can this attribute have? The name, the person only has one name reasonably, but maybe we have also phone. And the person can, of course, have more than one phone number. there is no way to model the cardinality in astah. We can write, if we wish, that the person has 0 to any number phones. For the name that is only there, the person has just one name, so then we should in this case maybe write 1 or 1 to 1. But okay, we can if we wish. I don't know if we wish to clutter the entire model with the cardinality like this. I would suggest rather to make a note. Then we don't have to put anything here. And now we can say if it can be 0 or not. We decide by whether we place a mark here or not. So that was the attributes. So now let's create another table. Let's say that the person lives at an address. The address could have street, zip, city. So let's say that the address must have a street, zip code, and a city. So now let's look at relations. So attribute, by the way, is the same, called the same in UML, right? An attribute is an attribute whether you use UML or IE notation. And an entity, so this is the symbol for entity, it corresponds to a class. And now we look at relations, which corresponds to associations. So there are 4 kinds of relations here. So first let's look maybe at the many-to-many relation. There. So now we see the crowfoot here and here. So the crowfoot means many. And this round thing here means 0. So that's 0. And that's many. So this is the IE way of drawing 0 to 2.0 to many, like this in UML. This would be UML. Right, we can give the cardinality a name. I mean, sorry, the relation a name. Let's say the person doesn't say very much, lives at the address. So as you can see, the lives at went towards close to the person entity, and that means we should read person lives at address. We can also go the other way around and add a name close to address. What could that be? Address, person, address is whom of, if we wish. Like this. So that went close to address, which means we should read address is whom of person. Okay, we should write at least one of those, but if that is illustrating enough, then we don't have to use both of them. So this is perhaps the correct cardinality, right? 0 or more persons can live at 0 or more an address can house 0 or more person, and a person can live at 0 or more addresses. Makes sense, I think. But just to illustrate, let's use the other kinds of associations as well. So we have this non-identifying relationship. So I will soon tell you what non-identifying means, but first let's look at the cardinalities. Here we can change. Now it's 0 or more, as can be seen here. And we can change to 1 or more. So this vertical line there means 1. Right, and you can see here at the other end there's the symbol for 1, and there the symbol for 0. So it means 0 to 1 in UML. Okay, we can also have 0 or 1. Yeah, we already talked about 0 or 1, the other end. Okay, but we can only have more in the child end, which was the last. I drew it from here to here. If we want more at the other end, we have to draw it the other way. Right, so that's that. Parent is required or not means whether to allow this 0 here. That's the symbol for 1 now. And if I uncheck parent is required, it becomes 1 or 0. Right, so whether we allow 0 or not. Okay, fine. We could also have a look at the identifying relationship, and then I'll say a few words about the difference between them. There, so the identifying relationship is a solid line. Apart from that, no big difference, except that parent must be required here. We can change between identifying and non-identifying here as well. So the idea is that identifying relationship means that the child, now you see by the way that when it is identifying that it got rounded corners, which is the symbol for a weak entity, which means it cannot exist without the strong entity at the other end of the relation. So that's the thing. A non-identifying relation means both entities are strong. They have squares at the corners, square corners, and both can exist independently. An identifying relationship means the child, the target, the many side, cannot exist independent of the person, and then it's a weak entity and the line is solid. But the address can exist. The address exists even if no one is living there, right? But maybe we have also another entity called phone. And the phone number does not exist unless someone, or does it? Okay, let's say that in this reality there is no phone number without someone that owns that phone number. So then we should use the identifying relationship to that one. And a person can have 0 or more phones, let's say. Okay, so that's the difference between identifying and non-identifying relationship. Again, that's more important when we start to design the database, when creating the logical model. So I again suggest maybe to only use non-identifying relationship in the conceptual model, or at least not to spend too much time worrying about whether we should use identifying or non-identifying relationship. Right, anything more? Yes, there is also inheritance. Let's use inheritance. Let's say that the person can be a teacher. And this is the symbol for inheritance. So this means that the teacher is a person. So inheritance in conceptual model and also later when it comes to database design is quite different from inheritance in programming. In both cases, it's supposed to illustrate some kind of is-a relationship, but there are numerous differences. Okay, so for those that have taken some kind of design course, for example, the one in this spring, and are reluctant to inheritance, I'll, as a side note, tell you that here in the database, there's no encapsulation that's broken by the inheritance, and the inheritance is dynamic. We do not have to manually edit something and recompile the database to change what inherits what. And also, it's not that the super entity person here will change without our knowledge. So the big disadvantages of inheritance in programming are not here in database design. So you don't have to be that afraid of inheritance. Still, it's useful to consider the rules for using inheritance, namely that it should be an is-a relationship. Teacher is a person, yeah, that's true. And the superclass should be a generalization of the subclass, meaning the superclass is valid in more situations than the subclass, but sub-entity, but not as good at particular situation, because the sub is a specialization. The subclass is a specialization of the super entity. It's better at the specific situation where it's used. It has more information that's of interest for the specific situation where there is a teacher. And finally, that everything in the super entity person should be relevant also in the sub entity teacher. So these are 4 rules. 1, 2, 3, 4 that ought to be met in order to use generalization. Why the 4th rule? Because we don't want a teacher that has a lot of data in the person, which is, a lot of instances of the sub-entity that which contains data in the super entity that are completely irrelevant, that are of no use, have no meaning in the teacher. That would be very confusing, because remember the first rule, that the teacher is a person. So if the person then has some data that the teacher should not have, then it will become quite confusing, and the teacher is in fact not a person in that case. But still, even in spite of the fact that generalization or inheritance here in the database world is not as dangerous as in the programming world, we still ought to ask ourselves, is there really any point of using inheritance, or is it just complicating the diagram? And I think often it is just complicating the diagram, but we'll come back to that when we start to to create conceptual models. So that was in fact everything about the symbols used in the conceptual model, I think. Let's see, is there anything else? Maybe one more thing is worth saying, and it's that there will be things that we won't be able to model. For example, things that are related to values of instances. Say that a person that has a certain phone number is not allowed to live at a certain address, even if it's strange rule. Rules like that are related to values of entities cannot be modeled in the conceptual model. So we have to add that. We have to simply write text specifying such rules. Okay, but that's all about models. Those were the basics of the ER diagram.